Welcome all to Newton's laws of motion class 11, in which we'll discuss about friction. First of all, we'll discuss what do you mean by this term friction. If you are considering that there is a surface and we are exerting some force on the surface along this direction, let's say that force is represented by F. Now, according to Newton's third law, we know that for every action there will be an equal and opposite reaction. So we can say that the reaction force exerted by the surface will be have the same magnitude but in opposite direction. So let's say this reaction force is making some angle theta with respect to the vertical. So if I'm just representing this action force as nothing but Fa and the corresponding reaction force as nothing but Fr. Now we can resolve this reaction force into two components. One component of reaction force which is perpendicular to the surface, that reaction force we can take it as something but Fr cos theta, and this is the component of reaction force perpendicular to the surface or normal to the surface, which we call it as nothing but normal reaction. So just remember that this normal reaction is not a new kind of force. It is nothing but the component of reaction force perpendicular to the surface. Same as like that, we can find out what about the component of force which is parallel to the surface, that we can take it as nothing but Fr sine theta. So this component of force which is parallel to the surface is known as nothing but friction. In general, we'll represent it by small letter f. So remember that normal reaction is the perpendicular component of reaction force, and friction is nothing but the parallel component or the component of reaction force parallel to the surface. So from these informations we can write the value of this Fr sine theta is equal to nothing but F, and the value of Fr cos theta is equal to nothing but normal reaction. Now if I am just dividing this equation number 1 and equation number 2, we'll get it's something like this. Fr and Fr is getting cancelled. Sin theta by cos theta can be written as something but tan theta, that is equal to F divided by N. Or you can write the value of frictional force is equal to normal reaction into this tan theta. For a particular pair of surface, this tan theta will be a constant, that is known as nothing but coefficient of friction. So it is represented by mu. So we will write this F is equal to mu into N. Now over here, this angle theta is known as nothing but angle of friction. So just remember that angle of friction is not the angle between frictional force and the reaction force. It is the angle between reaction force and normal reaction. So this angle is called as nothing but angle of friction. And for the calculation of frictional force, we can use this equation F is equal to mu into N. And just remember that whenever we are using this equation F is equal to mu into N, it is not always going to give the value of friction. It is going to give the value of maximum possible value of friction that a surface can exert. So this will give the value of maximum friction or maximum possible value of friction. We'll discuss in detail about this, then you'll come to know that what do you mean by this maximum friction. Now just consider a situation that a block is kept on a rough horizontal surface where the coefficient of friction between these two surfaces is equal to, take it as 0.4. And consider that the mass of this object is nothing but 1 kilogram. So you can write what are the forces acting on this object. Weight of this object mg is going to act in downward direction. Mass, if you are taking it as 1, and acceleration due to gravity is nothing but 10. So you can write the weight of 10 Newton is acting in downward direction. Now over here you can just consider that normal reaction exerted by the surface N is acting in upward direction. So in equilibrium condition, the block is not moving or the block is not going to move in upward or downward direction. So the net force acting in upward should be equal to net force acting downward. So we can write the value of normal reaction is equal to mg, that is equal to 10 Newton in this situation. Now if you are using this equation for the calculation of friction that we just discussed, that is F is equal to mu into N, mu is 0.4 and n is nothing but 10, then you will get the answer as nothing but 4 Newton. Now let's see whether the frictional force acting on this block is 4 Newton or not. So consider the similar situation over here. We are having an object of mass 1 kilogram which is kept on a surface. The coefficient of friction between these two surfaces is 0.4. Now our aim is to find out what about the value of frictional force acting on this object at this instant. So over here we are not exerting any external force on this object, so this object is not trying to move. So the frictional force acting on this object will also be equal to 0. So in this situation, frictional force acting on the object is not equal to 4 Newton, but it is equal to 0. So friction force is equal to 0 when the applied force is equal to 0, because friction is always trying to oppose the relative motion. If the object is not trying for any relative motion, there will not be any friction. Now let's say we are exerting a force of 1 Newton on this object. So if you are exerting a force of 1 Newton, then this 1 Newton is not sufficient to displace this object, because friction can exert a force of up to 4 Newton. So if you are exerting a force of 1 Newton and if the object is not moving, it means that still the net force acting on this object should be equal to 0. That means friction will exert a force of 1 Newton. So over here we can write when the applied force is 1 Newton, then the value of frictional force will also be equal to 1 Newton. Now if I am exerting a force of 2 Newton, which is not sufficient to displace the object, then the frictional force will also change to 2 Newton. When I am exerting a force of 3 Newton, the frictional force becomes equal to 3 Newton. And if I am increasing this force to 4 Newton, then the value of frictional force will also be equal to nothing but 4 Newton. But if I am exerting a force of 5 Newton, so this force is sufficient to displace the object. So here this object will move, and the frictional force acting on this object will be equal to 4 Newton only, because the friction force cannot exert a force more than that of 4 Newton in this situation. So now a 5 Newton is acting on the object and 4 Newton friction, so the object is going to move with an acceleration or with a net force of 1 Newton. So just remember that whatever the value of friction that we are calculating by using this equation mu into n is not representing the value of friction, but it is representing the maximum possible value of friction. So over here, if you are drawing a graph which is showing the relation between the applied force with respect to frictional force, you can observe the shape of graph will be a straight line initially. When the applied force is 1, the frictional force will also be equal to 1. This thing is happening up to when the value of applied force is 4, then the value of frictional force is also equal to 4. And when the force is more than the maximum value of frictional force, this object will just start its sliding motion. Then there will be a slight decrease in value of friction. Then the friction will be equal to a constant. So we can just mark some points, like from point A to point B over here. We can say that the object is at rest. So the frictional force acting on the object when it is at rest is known as nothing but a static friction. And this one, point B, is representing the maximum possible value of friction, which is known as nothing but its limiting friction. And the frictional force acting on the object when the object is moving is known as nothing but a kinematic friction or kinetic friction. So just remember that the kinetic friction is slightly less than that of limiting friction if they are not given any separate coefficient of friction for kinetic friction. Then we can take it as it is same as like the value of limiting friction, but there will be a slight decrease in value of kinetic friction as compared to that of limiting friction. So remember these basic things related to friction. The force which opposes the relative motion between the surfaces is called friction, or it is the component of reaction force parallel to the surface. Now we'll discuss about different types of friction. So as we discussed, the static friction, the frictional force acting on an object when it is at rest, is known as static friction, or the magnitude of the static friction is always equal to the magnitude of applied force, and the direction is opposite to the direction of applied force. And the next one is limiting friction. As we discussed, the maximum value of static friction is known as nothing but a limiting friction. Next one is kinetic friction, the frictional force acting on an object when it is in relative motion with the surface is called kinetic friction. The magnitude of kinetic friction is slightly less than that of limiting friction. So for the calculation of kinetic friction, we'll use that equation F is equal to mu K, represents the coefficient of kinetic friction into normal reaction, where this mu K is known as coefficient of kinetic friction. Now in a question, if they are not mentioned specifically the value of coefficient of kinetic friction, then whatever may be the value of mu which is given, we'll take it as the same for the calculation of kinetic friction as well as for the calculation of limiting friction. Hope so that you understood whatever the things were discussed in this class. If you are having any doubt, please contact. Thank you.